In this video, we are going to study some basic terms of fuzzy sets such as support, height, normality, subnormality, core, scalar cardinality, and level set. We will also study some illustrations explaining these terms. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. Let us get acquainted with some basic terms of fuzzy sets. Let A be a fuzzy set on X, where every X belongs to universal set X. First basic term is support. Support is all those values of X for which great value A of X is positive. It is denoted by sup A. So sup A is all those X belonging to X such that A of X is positive. Graphically, for a fuzzy set whose graph is triangular like this, values between these two extremes is the support A. For a fuzzy set whose graphical representation is trapezoidal like this, values of X between these two extremes is support A. Support is thus set of X on which fuzzy set A is supported. Moreover, since support is concerned with positive great values, sup A is also strong zero-cut A. Next basic terms are height, normality, and subnormality of a fuzzy set. First, height, which is denoted by h of A, is the maximum great value A of X. Graphically, for a triangular fuzzy set, this is height of A, h of A, or for a trapezoidal fuzzy set, say for this is height h of A. Next, normal fuzzy set. Normal fuzzy set is one whose at least one element has great value 1. This triangular fuzzy set is normal because this element X has great value 1. Or in other words, we can say that normal fuzzy set is one whose height HA is 1. Third is subnormal fuzzy set. This would be one whose height is smaller than 1. Here this trapezoidal fuzzy set is subnormal because its height is less than 1. Let us understand these things through some examples. Now let us see some illustrative examples. For universal set X, 1, 2, 3, etc., 10, A of X is x upon x plus 1 and B of X 1 minus x upon 10. Here, height of set A, h of A, is 10 upon 10 plus 1, 10 upon 11. Because for x equals 10, A of 10 is 10 upon 11, which is maximum. For set B, height h of B will be 1 because for x equals 0, P of 0 will be 1 minus 0 upon 10, 1, which is maximum. Here, since h of A 10 upon 11 is less than 1, we can say fuzzy set A is subnormal. And since for fuzzy set B, h of B is 1, we can say that B is normal. Consider another set C defined on set of natural numbers and given as C of n equals n minus 1 upon n, which is same as 1 minus 1 upon n. Its height h of C is 1 because for n equals infinity, C of infinity will be 1 minus 1 upon infinity 1. Hence, C is normal. There is one correction. This set X starts with 0 and hence height of B equals 1 is justified. Next basic term is core. Core of fuzzy set A is written as C of A and it is defined as all those values of set X such that grade value A of X is 1. In short, we can say that core of A is 1 cut A. For universal set X 0, 1, 2, etc. 10, let A of X is x upon x plus 1 and B of X 1 minus x upon 10. Core of A is 5 because if A of X is 1, 1 will be equal to x upon x plus 1, that is x plus 1 equals x. We see that for no value of x belonging to capital X, this equation has any solution. Hence C of A is 5. Core of B, C of B is 0 because if B of X is 1, 1 will be 1 minus x upon 10, x will be 0. Hence core of set B is 0. If we have fuzzy set C such that C of X is defined as x minus 1 upon x, and for C of X equals 1, 1 will be x minus 1 upon x, x will be x minus 1. For no value of x, this equation has any solution, which implies core of C, C of C is an empty set phi. These C of A, C of B and C of C are more appropriately written as core of A, core of B and core of C. We can show core graphically for a fuzzy set whose representation is triangular. This value x1 for which grade value ax is 1. Therefore, core of A here is x1 for a fuzzy set represented graphically in the form of a trapezium. Values from x1 to x2 for which A of x is 1 is called core of A, which in this case is closed interval x1 x2. This also means the core values have full membership for these fuzzy sets. Scalar cardinality. It is the sum of all membership grades A of x of a fuzzy set A. It is denoted by absolute value of A, which is summation A of xi, where I runs from 1 to n. Scalar cardinality is also known as sigma count of A. Let us find scalar cardinality of fuzzy set A if A of x is 0.5 upon x plus 0.4 upon y plus 1 upon z. Here 0.5, 0.4, 1 are the grades of membership of the elements x, y and z about which we have discussed in my previous videos on fuzzy sets. So here scalar cardinality modulus A will be 0.5 plus this 0.4 plus this 1, that will be 1.9. Universal set X is A, B, C, etc. J, and fuzzy set A is 0 upon A plus 0.2 upon B plus 0.5 upon C plus etc. plus 0.1 upon J. We have to find sigma count or scalar cardinality of fuzzy set A. Scalar cardinality or modulus A will be sum of all the grade values 0, 0.2, 0.5 etc. of the corresponding members of universal set X. So that will be 0 plus 0.2 plus 0.5 plus etc. plus 0.1. This sum is 3.5, which is the scalar cardinality of A. Let C and D be fuzzy sets defined on X 0, 1, 2, 3, 4 and 5 as Cx equals x upon x plus 2 and dx x upon x plus 5. We have to find cardinality of C and D and cardinality of C intersection D. Cx equals x upon x plus 2 gives us 0 upon 0 plus 2, 0, 1 upon 1 plus 2, 1 upon 3, and 5 upon 5 plus 2, 5 upon 7. In decimal form, similarly, t of x is x upon x plus 5. That will be 0 upon 0 plus 5, 0, 1 upon 1 plus 5, 1 upon 6, etc. 5 upon 5 plus 5, 10. In decimal form, modulus of c will be 0 plus 0.33 plus etc. plus 0.71. That will be 2.81. Cardinality of d equals 1 upon 6 plus 2 upon 7 plus etc. plus 1 upon 2. That will be 1.77. Cardinality of C intersection D is minimum of cardinality C and cardinality D, which will be in this case cardinality D 1.77. Cardinality of A intersection B plus cardinality of A union B is cardinality of A plus cardinality of B. This is for any two fuzzy sets A and B defined on a finite universal set capital X. Suppose universal set X is x1, x2, etc. xn, then cardinality of A is summation A of xi, where I runs from 1 to n, and cardinality of B is summation P of xi, where I runs from 1 to n. Now cardinality of A intersection B will be summation A intersection B of xi, where I runs from 1 to n, which is summation from 1 to n minimum of A of xi and B of xi, and cardinality of A union B will be summation A union B of xi, where I runs from 1 to n, which we know summation from 1 to n of maximum of A of xi and B of xi, when A of xi is less than B of xi for I equals 1 to etc. n, then summation of minimum of axi and bxi will be cardinality of A, and summation of maximum of axi and bxi will be cardinality of B. So adding 1 and 2, we get the result cardinality of A intersection B plus cardinality of A union B is cardinality of A plus cardinality of B. Level set LA is set of all non-zero grid values A of xi of a fuzzy set A is called level set L of A. Mathematically, level set A is defined as set of grade values A of x such that A of x is non-zero, where x belongs to capital X. For example, let x equals a b c d e f g h I j, and fuzzy set A is 0 upon A plus 0 upon 2b plus etc. plus 0.1 upon j. Then level set L of A is all non-zero grade values of A, such as this 0.1, this 0.2, this 0.5, and this 1. Note that we have excluded grade value 0. Another example, for x equals 0, 1, 2, 3, 4, 5, A of x is defined as x upon x plus 2. Therefore, fuzzy set A will be 0 upon 0 plus 2, 0 upon 0 plus 1 upon 1 plus 2, 1/3 upon 1 plus etc. plus 1 upon 7 upon 5, and level set L of A will be 1 upon 3, 1 upon 4, etc., excluding grade value 0. Now one interesting example. Fuzzy set A is defined on real set R as follows. A of x is 1 minus e raised to minus x when x is non-negative and it is 0 otherwise. Here a of x will be 1 minus e raised to 0, 1 minus 1 upon e, 1 minus 1 upon e square, 1 minus 1 upon e cube, etc. 1 minus 1 upon e raised to infinity, that will be 1 minus 1 0, 1 minus 1 upon e, 0.6321, 0.8646, etc. 1 minus 1 upon e raised to infinity 1. So in this case, level set A, L of A will be 0.6321, 0.8646, etc. 1. Remember, here we have excluded membership grade 0. Viewers, if you like this video, please click the like button. Share this video with your friends and classmates. Subscribe to this channel. Post your constructive comments to make the videos better. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. See you in the next video. Until then, keep watching Number Collage. Thank you.